Hello everyone, my name is Alex. I'm head of MLOps and DevOps at Zencoder. I also dabble as DevRel, and in general, what I like to call Dev Ask Me Anything. It's a startup, so you have to wear many hats. Today, I will be talking with you about AI coding agents, how you can code them, how you can use them, how you can leverage them to make your everyday life easier and be more productive. Now, recently you might have come across headlines like this, where in this case Mark Zuckerberg mentioned in his interview that AI will soon replace developers, and in this particular case he even went as far as saying that mid-level engineers will be replaced pretty soon. Now there are two main sort of sources for those headlines. First of all, of course, new models, new AI or LLM models are coming up, being released. For example, here, the recent release from Google of Gemini 2.5 Pro, and they, of course, show that their new model beats all the previous models on the benchmarks, which is always the case, right? Now, for us, for coding agents in particular, we are mostly interested in the three code-related benchmarks, which I highlighted here in red. Now, the problem with benchmarks is while it is good to see that models are becoming better on them, it's a good way to compare models with each other. All those benchmarks are not always transferable one-to-one to a real world. What I mean by that is, for example, if we look at either polyglot, the main idea behind this dataset is that an LLM or AI is presented with a list of tasks, and it essentially needs to create a function. It needs to create a class or method that would fulfill that task. So essentially, it's one or single file modification. However, reality of software development is not that simple, right? So usually you need to modify at least multiple files inside the repository, or sometimes you might even need to modify files across multiple repositories at the same time. So basically, even though there are improvements in the quality of AI, of LLM, they're not always transferable one-to-one in the real-life world. So you might not see as big of an improvement as you would see on the benchmarks. So that's one source of those headlines. And the second one is AI agents, which is the main topic of today's talk. So basically, we will first cover what is AI agent. Then we will go through a live coding session where we'll see how you can create the coding agent on your own, right? And you will see how they can also interact with each other with multi-agent collaboration. And then we will briefly talk about what is next for the developers, what all those new improvements, what all those new changes mean for the future of software development. So yeah, basically by the end of the talk, we will potentially build an AI which might probably replace you, or maybe not, we'll see. So first things first, let's define what is AI agent. Now, AI agent can be defined as a software that performs tasks on behalf of a user. And you might say here that any software performs tasks on behalf of the user, right? Especially if we're talking about current generation of coding assistants, and they essentially perform tasks of code generation on your behalf. They perform tasks of documentation generation on your behalf. And you can just essentially tap, get 1,000 lines of code in a couple minutes, and then spend some time on debugging that code. Now, the main difference between AI agents and classic software is that AI agents follow multiple design patterns, which you can see here on the slide. So first of all, they have what's called tool use. So they can basically have access to the tools, to the list of tools at their disposal. And those tools could be pretty much anything. It could be doing a web search. It could be accessing some local file system. It could be accessing RESTful APIs and so on. So basically, any tool LLM can use to gather information, to perform actions, and so on, it can use it. Then, of course, AI agents can also do some planning. So they don't just blindly perform the task, perform code generation. They can first come up with a plan on how to tackle this specific task at hand, and they then will follow that plan. They can also reflect on their own work, on their own planning step, on their output, or they can also reflect on work of other agents. And this is where we come to this fourth design pattern, which is multi-agent collaboration. So basically, you can have multiple agents working together towards the same goal. And those could be either working together as in colleagues, where they, for example, one agent performs half of the task and then the other agent performs the second half of the task, or they can also critique each other. So for example, you could have one agent which critiques the work of the second agent, and then the second agent iterates on this critique and so on. But basically, yeah, those patterns are what differentiates AI agents from the typical or from the classical software. And you can think about AI agents like I guess, a Roomba vacuum cleaner. The software itself on the vacuum cleaner is an AI agent. However, to perform the task of cleaning the house, right, it needs also some things on top of that. So just software is not enough. The vacuum cleaners, they also have tools. So that could be brushes, that could be wheels to move around and so on. They can also do planning. And for some reason, ChatGPT thinks that robot vacuum cleaners move in this weirdly shaped pattern. But it is AI being AI. There is no still yet multi-agent collaboration unless you count these for the vacuum cleaners. But maybe in the future, they will be able to also talk with each other. They would be able to talk with the other home appliances and so on. Yeah, basically. Now, why is this important? To answer that question, let's first talk about what we as developers spend our time on during the work hours. And I will give you a few seconds to think about this. Spoiler alert, it's not drinking coffee. In reality, and this study was done actually 10 years ago. However, I don't think much has changed since then. Now, in reality, 70% of the time developers spend on understanding. That could be understanding the code base, understanding the requirements, understanding tasks, and so on. So basically, most of the time, developers are not spending on writing the code, they are spending on understanding. Now, if we juxtapose this with the agentic design patterns, which we just discussed, we will see that, for example, for the tool use, we of course have editing. We need to use tools to edit the code. We need to use tools when we are outside of IDE, I know, Googling something and so on. And of course, for UI interactions, we also need to use tools. Then, of course, for planning, we need to understand the task at hand. We need to understand the requirements, because otherwise it's hard to do planning of the work, right? There is also reflection. Of course, we don't just blindly follow the requirements. We don't just blindly follow the task, I hope. We also can think about different ways to solve the task. We can think about different ways to tackle the problem, and so on. And of course, we don't usually work in a vacuum. We have colleagues with whom we can work together, we can collaborate, and this is where basically multi-agent collaboration comes in. And of course, for that, follow that, you will need to have a good understanding. You probably also need to navigate the code base, you need to spend some time outside of IDE, in Slack or whatever. But basically, all of the design principles can be directly juxtaposed with what developers do in their free, oh, sorry, not free, but of course, what they do in their work time. Now, with that, let me switch the sides and let's finally do some coding. All of the code which I will be showing today is available on this repository over here, either on QR code or the link below. And the way I structure the coding session is I will go through several stages, and hopefully not those stages. But basically, I will go through several stages. We will start with a simple baseline where we won't have any agentic patterns at all. And then we will slowly build on top of the previous stages to come to the final step of multi-agent system, which will work together to fulfill the task on our behalf. So let me switch here to the Jupyter notebook I have here. Let's see. All right. So let's start with our baseline, right? And if you used AI in any capacity, if you used any LLM like OpenAI or Claude, you probably have experienced something similar to what we will see right now in the baseline. But basically, and again, if you are not familiar with Python, it's not a problem. All of the code is pretty simple, pretty simple to read, and pretty easy to understand. Now over here on this baseline, basically what I do is I will be using the most recent model from OpenAI, namely GPT 4.1. And basically over here, I'm just defining the code to query the model so that this function will send the input from us, from user, to the LLM, and we will get the response from GPT 4.1. Now, the problem with the LLMs is that they are living somewhere in the cloud and they don't have access to real life world. What I mean by that is, for example, they can't give us a response time from Google or any website for that matter. So it does try to be helpful, and I think it probably will, it does give us some command to run to get the answer. Unfortunately, on its own, the LLM, in this case GPT 4.1, isn't able to help us. The same goes with the access to local machine. In this case, in that it doesn't have access to my local computer. Again, it does try to help me with providing some bash commands to list the packages. Unfortunately, even for those simple tasks, it can't really help me. And especially if we are going into some more sophisticated tasks that require access to local machine, for example, running a Docker image, the LLM would fail here and wouldn't be very helpful. And the same goes with the new and updated knowledge. Now, in this case, the GPT 4.1 has a more up-to-date knowledge. If you try the same query with an older model, like GPT 4.0, for example, it wouldn't know anything at all about Python 3.14. In this case, because the knowledge cutoff for the model was, I think, in June 2024, it does have some knowledge about Python 3.14, and it does provide some links for us as well. However, still the knowledge is not up to date, right? It is 2025, May 2025 right now. And basically the gap between the LLM knowledge and the real life world is essentially 1 year now. And a lot has happened since then. So yeah, basically, even though it does try to be helpful by giving us commands, by giving us answers based on its knowledge, it's not really that helpful in real life world, in real life situations. Now let's see how we can improve on that by introducing the tool use to the LLM. So let me switch for that to the basic agent over here. All right. So I'm again using the same model, GPT 4.1 for that. And what we will be using on top of that is what is called the React framework. React stands for reasonable attack. And basically, we will be instructing LLM to go through the loop of multiple stages, namely thought, action, pause, observation, and answer. In the thought step, the LLM would need to think about what action it needs to perform to get the answer or to get the information to give us the answer. Then it needs to decide on the action itself. Basically, as a response to our request, it will need to send the actual action it wants to perform along with some inputs potentially. Then there is a pause step where basically the action should run on behalf of LLM. Then during the observation step, the output from the action will be sent to LLM. And then based on this observation and the initial input from the user, the LLM hopefully will come up with an answer. Or if that information is not enough, it will go to the second loop, to the third loop, and so on, until it gets us the answer or until it runs out of loop iterations. And this can pretty easily be implemented through this system prompt over here. Basically, I'm instructing LLM to follow the loop of React framework, which I just described. Right, so you run in a loop of thought, action, pause, observation. I use thought, use action, and then we also provide a few actions available for LLM to use or to choose from. In this case, those would be ping. So basically that would perform the ping command on behalf of LLM. We have bash, which would allow LLM to execute any bash commands. And we will have web search, pretty basic web search, which will allow LLM to do web search. We also have some example session over here for LLM to use as a reference. So, for example, here the question from the user could be, how many islands make up Madeira. I live on Madeira, so it's a sort of nice small Easter egg for that. And then the thought from LLM should hopefully be that it needs to do a web search for the Madeira. Then it would need to perform to reply with an action, namely web search, and then the input for that action. In this case, that could be just Madeira. Then during the pause, the actual web search will happen. And then based on the web search, based on the observation from that web search, the LLM should hopefully come up with an answer. In this case, that would be 4 islands. We are using the same code to query the LLM. We will just directly send the input from us, from the user, along with the prompt, with the system prompt we've seen above. And then let's also define our 3 actions, 3 commands to perform actions, namely ping, bash, and web search. Let's test them out. And ping for google.com returns 200 milliseconds. I do indeed have Python 3.12.6 installed locally. And for the web search for Python 3.14, it gave us a lot of information from the website. All right, so this seems to be working fine. Now let's compile this in the dictionary just to make it more easily accessible. And then the main implementation of React framework happens basically in this function over here, where we are going through the React loop. We start with the sending the query of the user query to the model. Then, based on the output from the model, we check if there is any action that model decided to perform, which will be signified by this action semicolon prefix of the string. And if there is an action, we get the list of actions, we perform that action, and give the result of running that action to the LLM to hopefully give us the answer. And then, of course, if that information is not enough, we will go to the second loop, to the third loop, and so on. Now let's try pretty much the same prompts, the same questions we had before in the baseline, but now with this basic agentic behavior. So let's first try to get the response time for Google. In this case, the LLM decided to perform action ping for google.com, which is the correct action. It got the answer from the action, and then as an answer to our initial question, it gave us the rounded number of milliseconds or seconds for the ping. The same should work with the Python packages, right? So it decided to perform the action bash with the input of pip list, which gave the LLM a bunch of packages I have installed locally. And then based on that, the answer from LLM was, I guess, a sort of summary of those Python packages which I have installed locally, showing a representative sample apparently. All right, and let's see what will happen with our Python 3.14 question. So the action the LLM decided to perform is a web search, which makes sense, right? It's pretty much the actual question of ours was in Python 3.14. It got to the logical website from python.org with a bunch of information, and somewhere below, let me scroll all the way down, somewhere below, it should give us the answer based on the observation from that action. Namely, over here, it summarized some new features, changes in Python 3.14, a few PEPs, a few new features, some changes. So basically, with just a single system prompt like this, we already are able to significantly extend the capabilities of LLM beyond it just being a sort of knowledge base. It now has access to web. It now has access to our local machine. It now has access to bash commands, right? So basically, it already can be much more helpful for us both in everyday life and in our coding journey. But of course, it wouldn't be very convenient to modify this prompt every time we need to add new action. And there could be a lot of different actions depending on what tool you want LLM to be able to use. Like, for example, if you think about Git, right? The Git itself has a bunch of different commands like git commit, git checkout, git branch, and so on. So you would potentially need to define each single git command as a separate action, and that probably would take quite a long time. Now, fortunately for us, there are ways to abstract all these tool definitions from us, from the end user. And one of these ways is MCP. So let me go back to the slides real quick over here. Let's see. So MCP stands for Model Context Protocol, and it was introduced pretty recently at the end of November last year, 2024, by Anthropic. So essentially, MCP is a protocol based on JSON RPC, which aims to facilitate the tool use and the development of those tools. It consists of two main counterparts, MCP server and MCP host, or MCP client. Now, MCP client could be our LLM, it could be some IDE, it could be any AI-enabled tool, basically. And then MCP server performs essentially two main functions. First, it of course interacts with the actual tool, performs the actual actions, right? So it could access some local resources. It could be an MCP server for the file system, so it could manipulate files, for example. It could also be MCP server that performs some API requests. So it could be MCP server which provides tools to access Jira, for example, or it could be tools to access, I don't know, flight radar, right? So basically anything that can be coded to be accessed through code can be converted to MCP server. And then through MCP protocol, the LLM can get the list of tools, can get any names, descriptions, and how to use them. And then again, through MCP protocol, it would send essentially the request to perform the action to the MCP server, and then it would get the response from MCP server with the result of running that action, or the result of running that tool. And it is pretty straightforward to create your own MCP servers. Let me switch back to our notebook over here. And let's go now to the agent with MCP directory. So first, let's see how we can implement our own MCP server. And you can do that in multiple languages. I think currently there are SDKs for Python, JavaScript, Java, and Kotlin, if I'm not mistaken. But essentially, of course, I'm sure that more languages will follow. But basically, over here, we have the tool, MCP tool, or MCP server, defined in Python. And Anthropic provided a nice fast MCP class from the MCP framework, which basically requires us to essentially just instantiate the server itself. And then through this decorator, we can convert any function into an MCP tool. So in this case, that would be a bash tool, which will execute any bash command for us. And of course, ideally you don't want to execute blindly any bash command, but for the sake of the presentation, we will allow that. But basically, those three lines is the only things that you would need, at least in Python, to create to create an MCP server for yourself. And as I said, anything that you can code can essentially be converted to MCP server. Now, along with that, we also would require a sort of description of how to call that server, that MCP server. And over here, I have a small JSON file which defines the MCP servers. In this case, the only MCP server is called bash, and it is run as Python command, right, with the args of just the name of the file, because it's essentially a Python script. So that's the only two things that it needs to be executed. But we will see later different ways beyond just Python script that you can execute MCP servers as. So let's now see how we can use those MCP servers along with LLM. So for that, first of all, we will switch to Anthropic. In this case, it would be Claude 3.7, I believe. Yep, it is Claude 3.7. The reason for this switch is initially Anthropic's Claude was better at using tools. However, now you might have heard that even OpenAI adopted the MCP protocol from the rivals, basically. So the recent models are also pretty good with following with using tools defined as MCP servers, but still here we will be using Tropic's Claude 3.7. Now, what we essentially need to use the MCP tools is we will need an MCP client, and in this case, the main functions or methods of this class is, first of all, we need, of course, to connect to servers to get the list of tools available for us to use, or for LLM to use. And this function is essentially responsible for that. So we just connect to each server in the loop, in the server config, and then get a list of tools from that server. And then we also need to, of course, send the request to LLM and then act accordingly to the response from LLM. So basically, we attach the list of tools we got from MCP servers in the format of tool name, tool description, and tool input schema, along with the user input message. And those things are sent directly to Claude 3.7 in this case. And then the LLM decides if it wants to just respond as a plain text or if it wants to perform an action or a tool use. And this is how we basically differentiate between those. Part of the response, there would be a content type. It could be either text or a tool use. And in the case of tool use, we will see what kind of tool it wants to use. So that will be basically tool name. And then what kind of input arguments it needs to be, we need to pass to that tool. Then we will perform that actual tool call over here. And then we will send the result of that tool call back to LLM. And then hopefully we will get an answer to our question. And then here I have a nice small chat loop where basically we will send the query into the text field and then proceed with this chat until we type the quit word. So let's start with our bash tool over here. We got connected to our server, which was run as Python bash tool fastmcp.py. We have one single tool called bash, and let's ask LLM to do something. Let's say list all files, and let's see what it will come up with. So in this case, it decided to call the bash command, the bash tool, with the command ls-la, which makes sense. And it got the list of files and basically summarized them. All good. Now let's see how we can extend this to multiple servers, to multiple tools. And for that, we will use the full JSON config over here, which basically defines 4 MCP servers. First of all, we have a file system MCP server, which is essentially an NPM package, which runs with few inputs, which is few arguments. We also have a web search realized through Brave web search, and it is run as Docker image. So over here we have some env file for the tokens. We also have a fetch web server, which would allow LLM to fetch any URL from the web. It is implemented as Python package. And then, of course, we have our bash MCP server, which we just defined a couple of seconds ago. So you can see MCP servers can come in all flavors and languages and ways to run them. Now let's now give those servers to our LLM and let's ask it to perform some actions. Right? First of all, let's see what's new in Python 3.14. So let's see if it will need to perform a web search to give us the answer. All right, so it decided to call the web search tool with the following query: Python 3.14 new features, release notes. Unlike OpenAI's GPT 4.1, it didn't just copy the questions from us. And then based on the response from the web search tool, it gave us the summary of new features. Let's also try to ask Claude to create a file called hello.txt with the content hello world. All right. Let's see. So hopefully it will be able to access our local file system. So in this case, it decided to use the tool write file with the following arguments. And let's actually see, we just got the new file on our local file system called as requested hello.txt with the content hello world. Great. So essentially, with just a few lines of code of basically the JSON config of MCP servers, we again extended the capabilities of LLM beyond just being able to answer questions based on what is seen in the training data. It is now also able to perform a lot of different actions, and those MCP servers can come in different flavors, and there are actually a lot of different sources where you can find MCP servers online. There are MCP registries, which contains hundreds of different MCP servers for tools like, for example, Grafana, Jira, and so on. So basically, you can give LLM access to any tools you use in your everyday working life, and basically, as we will see later, ask it to, for example, solve the Jira ticket. Now, let me quickly jump back to the slides for a few more seconds. All right, so we've seen MCP. Now let's see how we can make agents work with each other. Because of course, before that, all of the tools we had, or LLM had at its disposal, were essentially just a software, right? It was just API calls, it was just file system manipulations, and so on. However, you can imagine those tools being agents on their own, and then one agent could potentially call another agent to delegate a task, to ask the subordinate agent to perform some small subtask, and so on. And in our case, we will be building a system which contains 4 agents, and it will be hierarchical system where we will have supervisor agent, which you can think about as product manager, for example. And this agent will be able to call 3 other agents, subordinate agents, and those would be front-end developer, virtual front-end developer, virtual backend developer, and virtual DevOps engineer. And they also would be able to interact with us, with the client, to ask for any clarifications if needed. But generally, all of the manipulation of all of the interactions between those subordinate agents should happen through supervisor agent. There is no direct connection from one subordinate agent to another. However, of course, you can also implement this where in the system, potentially all agents would be able to talk with each other directly, not through the supervisor agent. It would really depend on what you want the system to do. Now let me switch back again to our Jupyter notebook. All right. And let's go to the final notebook of the day, which is multi-agent notebook. Now here I will be adding one more level of abstraction, namely length chain and length graph. And the reason for that is, of course, you can implement all of the cross-agent interactions on your own. It is essentially just structured inputs and outputs, and then some state manipulations on top of that. Why spend time on that when you can use the frameworks which do that for you, basically? So again, we will use the same Claude 3.7 here, and we will give it 4 tools, pretty much the same tools which we've seen before. Shell tool for the bash commands. It will also have access to Brave search, again, as we've seen before. It will also have access to file system manipulation. And there is also one more new tool, which I called human, which basically would allow LLM to ask back questions to the human. And then as discussed on the slide, we will create 4 agents. First, we will create agent supervisor, which will have access to 3 team members, namely front-end developer, back-end developer, and DevOps engineer. And the system prompt is pretty straightforward. We are telling the agent that it is a supervisor, overseeing the following 3 workers, and it basically needs to decide who is the next agent responsible to perform the task or to act next. And then once the supervisor agent is happy with the result, it should respond with a keyword finish, basically. We will give access to all the tools, all the available tools to this agent as well. However, in real life, potentially you probably would want agents to have access to different lists of tools, right? For example, you might have DevOps engineer or virtual DevOps engineer being able to access tools like Grafana or Prometheus or Datadog or whatever, right? But at the same time, you probably don't need front-end agent to be able to access that. But on the other hand, it needs to have access to other tools like Figma, for example. So the only things we basically need to create our supervisor agent is this piece of code over here, where we define what sort of nodes or what sort of handoff nodes are available for this supervisor node to call. And those are, again, our team members, and then, of course, end node to finish the task. With that, let's also define our 3 agents, namely front-end agent, back-end agent, and DevOps agent. As you can see here, we are using pretty much the same React framework as we've seen before. And again, we are passing all the tools, all of the available tools to those agents. And the prompts are pretty simple, although in real life world, of course, you probably would want to be more creative or be more specific with those prompts. But in our case, we are just defining the front-end agent as a front-end developer. And this agent can also ask for help from backend developer or DevOps engineer, and it can also ask for clarifications from the human client. The same goes with the backend agent. It can ask for help from frontend or DevOps engineer, and it can also ask for clarifications from the human client. And the same goes with the DevOps agent. It can also ask for help for frontend or backend developers and ask for clarifications from human. All of those agents or nodes in the terms of LangGraph are defined in a pretty straightforward manner through this command over here. And that's pretty much all we need to do to define those agents. Now, with that, let's also build a graph and let's also visualize that graph. So indeed, as we've seen before, we have the supervisor node or supervisor agent, which can talk directly with our front-end, back-end, and DevOps engineers, but subordinate agents can talk with each other. They only can talk through supervisor. Over here, I have just a small helper function to color the output, as we will see in a few seconds. So I won't go over that piece of code. And then the task for our multi-agent system would be to create a website for the conference. It needs to have 3 pages, namely intro page for people to submit the docs, and page with the submitted docs. I want the frontend in React, I want the backend in REST API, and the submissions should be stored in Postgres database. And also, it's always nice to have Docker and Docker Compose, so I also ask for that. And then we also mentioned that they can ask the human client for any clarifications. This part over here is basically all what is needed to initiate the execution of our multi-agent system. So let's actually start it and see what it will come up with. First, indeed, we went into supervisor, which decided to call the front-end developer. The front-end developer itself decided to check what kind of tools it has installed on the system. It got the answer, and then it went ahead to check the versions, Docker Compose version. All right, it decided to create a conference website directory, so here. So we already should be able to see some changes reflected locally. Indeed, we have a few directories already. We have the package.json, so probably it is doing npx command, which will potentially take some time because the npm install usually takes a few minutes. We can see the node modules appearing for us with a bunch of packages. All right, let's go back. And we already starting to see some of the code popping up over here. All right, some CSS, some TypeScript code. Let me scroll down here. So it did install some packages, and it started to implement the code over here. So it started with the Python. All right. Yeah, basically it will proceed to implement the website for us on our behalf. Now let me switch back again to the slides. All right, but it is always nice to fiddle around with the code, with the agents, with the LLMs, and see what you can build on your own. Of course, you don't always have time, and still you probably would want to be able to use those agents, be able to have those agents help you with your everyday tasks. And of course, there is a way for you to have them help you with your coding tasks, basically. With that, let me briefly talk about what we do at Zencoder. Zencoder basically is just a plugin for VS Code at JetBrains, and this plugin brings the agents to your IDE natively. You don't need to switch to any other IDE outside of what you are already using. And let me briefly showcase our agent basically solving the Jira task. Let me switch to VS Code over here. All right. So our agent, our Zencoder, is already natively integrated into Jira. So we have this Zencoder test over here. So basically we can tag any ticket from the Jira. Nope. I think that's the wrong account. All right. Space. Let's see. All right. So let's ask our agent to solve this ticket. Solve it. Create a branch called 42. Check out and commit changes. All right. So the ticket itself basically requires the agent to implement changes across multiple languages across the whole repository. So what our agent will do first, it will try to analyze the code base. It will try to understand the project. So it will check some Python files. It decided to also check across different languages. So this repository specifically contains 3 languages: Python, Go, and TypeScript. So it went ahead to check some Go implementation of the repository. Yeah, so it can take some time depending on the task which we have at hand. So it also created already a branch for us thanks to MCP support. Of course, you can attach any MCP servers. In this case, I have a Git MCP, which basically allows the agent to perform any Git commands locally on your machine. And we already see some changes being implemented in our repository, first in Python. Okay, we already have modified, I believe, 2 files over here. And then agent decided to switch to Go implementation of the repository. All right, so yeah, we also need to introduce this namespace thingy in the Go implementation of the server, as well as in Python. All right. Then we also, of course, as instructed, did git add and git commit. And this small sort of nice feature I have here is I instructed the agent through instructions to always Slack me when it is done with the task. Let's go back to our chat. And yeah, basically through the combination of NC patterns and MCP servers, it was able to basically pull the Jira ticket and then essentially do all the tasks surrounding the typical software development steps, right? So it created a branch, created a commit for us, and so on. So basically, in a matter of minutes, it was able to fix the ticket for us. All right, let's switch back to the slides one more time. Okay, so yeah, and if you were wondering, this is how those messages from Zencoder would look like in Slack, for example. And every time I get those messages, feels this meme. And of course, I can instruct Zencoder to not message you, but your PM or whoever you wanted to message, and not necessarily in Slack. Or you can, through MCP, you can connect to pretty much any messaging app whatsoever. And well, of course, these sort of improvements, or what you've seen now, probably made you think if it's time to switch the profession, right? Is still a good time to be a software developer? And of course, there are essentially two main sides to that question, to what's coming for the developers. Of course, you can think about AI replacing us, and there is also some variability as to if you see it as a negative or a positive thing. Because, for example, maybe you always wanted to be a goose farmer, and then once you are replaced by AI, you finally would be able to chase that long-lasting dream of whatever your heart wants you to be. Now, of course, at least for now, AI is not able to train itself without the data. So there is at least one job that is safe for now, namely writing the code for AI to train on, because still it requires a bunch of data for training, for model improvements. However, jokes aside, even with all of those improvements from on the AI side, on the agentic side, with things like vibe coding, you still hopefully need to, we still need to have a good knowledge of what's going on, especially if we're talking about some mission critical systems, especially about putting things into production. You still want to be able to understand what's going on. You still need to be able to read the code or debug the code. So what we as an encoder and me personally see as a sort of upcoming future for the software development is that we as developers would become more as managers of virtual agents, virtual junior developers, if you will. And we as humans would be more of reviewers, more of managers, as I said, rather than writing the code ourselves. So basically, we would be able to offload any mundane tasks, like for example, writing documentation, writing unit tests, and so on, to our army of virtual developers. We as people would be able to focus on more creative or more high-level tasks, more architectural tasks, and so on. So yeah, hopefully the future no longer doesn't look as dark as it did before. But of course, AI moves fast, so we'll see what will happen in a few years. With that, a couple QR codes for you to use. On the right is my contact details. If you want to connect on LinkedIn, if you want to follow up with any questions, feel free to message me, feel free to send a connect request. And on the left, you can see the QR code for our website, for zencoder.ai, where you can basically sign up for free and try the agents in your IDE already today. And with that, thank you for your attention.